Hello everyone, welcome back to the channel. Now in this video we are going to talk about a very special and important concept which is nothing but recursion. So, recursion is a methodology, a problem solving technique using which we can solve problems in a very efficient way, and your code also becomes very concise. So what is recursion? A recursion is a technique used to solve computer problems where a function calls itself to achieve the desired output. You might have read this line a lot of more times. A function calling itself is called recursion. But that's not the complete definition, right? It's a very important and fundamental concept that is used in implementation of a lot of data structure and algorithm. We have already implemented tree and all, right? And we have used recursion in almost every single implementation. So recursion plays a very important role in their implementation. It is used in searching. We used recursion in binary search. Sorting, if you remember, we used it in merge sort and quick sort, okay, which is actually a divide and conquer algorithm. We used it in a lot of implementation in T data structure. We are going to use it in graph as well. DP is not possible without recursion. Backtracking is also a very interesting concept, which is not possible without recursion. And there are many advanced algorithm and data structures which use recursion very much. It is a very critical part of the implementation. So if you understand recursion and its implementation, right, then only you can understand those advanced data structures as well. So recursion is a very important concept. There is no denying that. For every single recursive problem, there is an iterative solution. Yeah, that's correct. We have two types of recursion, head and tail recursion. Head recursion is where you made the recursive call first and then you perform the logic. Okay, that becomes actually slow. And then you have tail recursion where the last line, last step of your method is the recursive call. And this tail recursion is actually faster than head recursion. I'm going to explain you why. Okay, it's faster because the compiler understand the tail recursion when you don't have any other function or logic written after that, and it uses the go-to statement. Go-to statement, what it does, once you are done executing the last statement, right, it directly navigates to the first when the method execution started, right, it takes the call at that location, and that's why it becomes faster. How to convert head recursion to code to tail recursion? To be honest, it is not possible to do this in every single scenario, but if we pass some extra parameter, you can actually do that. And we are going to solve problems on this, so don't worry, you will understand this. When to use recursion? A lot of people learn recursion and they think they know recursion, right? But when the time comes to actually use it, they are blank. You don't understand, oh, we actually use recursion there or not. So when do you actually use it? When you are performing an operation again and again, okay? That's where we are doing the recursive calls. When you're performing an operation again and again on the input till the condition beyond which calculation cannot continue, that is actually called base condition, okay? So that is where you use recursion. In short, also I have written logic is same, input getting smaller till it reaches base condition. So yes, this is the essence of it, but I understand that getting the intent, the intuition of using recursion does not come just like that or with some few of the problems. That comes slowly with the time. So what is recursive leap of faith, and why we say if you have the solution of n minus 1 input, you will get the output for n by adding 1 to it. So the answer is very simple, because of the recursive logic. Okay, I have written, I'll explain already, I'm going to explain. So the recursive logic that you write, right, which keeps on calling your recursive method, keeps on calling until it reaches base condition. Because of that particular recursive logic, we take this recursive leap of faith. So once you do that recursive call, that means you're taking that recursive leap of faith, and the only thing you know is that where to stop this recursion, and that's where you write the base condition. It could be a little bit confusing to understand at first. It's completely natural, because to be honest, I was not able to understand at first. I thought just running that factorial program was enough to understand recursion, but that's not the real case scenario. Base condition, I have already told you. What is it and why we need it? Because you have to terminate your recursive call at some point of time. That's why this you need to have it in your recursion. Okay, without base condition there is no recursive call. Now I know when people talk about recursion, the first program that take is the factorial number. I understand why, because there you can explain the number keeps on multiplying and the input is getting reduced, but that program does not reveal the actual intent. I mean, yes, you are able to calculate factorial. To be honest, it was not that much intent revealing for recursion to me. So that's why I'm going to use the simplest and best example, which is printing 1 to n or n to 1. Trust me, this is the best example to understand recursion. There are so many advanced programs that claim that using, if you are able to run these programs, you will understand recursion. Yes, they will enhance your understanding of recursion, but they won't be able to like teach you recursion, the basic concept of it. For that, this is the best program according to me. You might disagree. I don't have any problem with that, because this is a concept which everyone understands in a very different way. So let's understand this program in a very simple way. Print 1 to 1. What we did. So we have written the logic, the output that we want. We want to print end to end. Let's say you don't have a base condition right now. You have just printed the number and then you did the recursive call with the reduced input. In case of this program, -1. So this is your recursive leap of faith. You have told the program, if you are able to find the answer of n minus 1 and add 1 to it, you will get the answer of n. This is a repeating logic. That's how you prepare those recursive calls. And in the end, obviously base condition, because your recursive program has to terminate at a point. That is why base condition is mandatory. So how this program is going to run? First, it is going to check your base condition, which will be false. It will print 5, then it will reduce 1, which will become 4. Again it will run, base condition will fail. It will print 4. It will keep on printing 3, 2, 1, and when it comes to 0, that is where you want to terminate your recursive call. So when 0 becomes 0, you terminate it with your base condition. And you can also consider this as an example of tail recursion. Okay, I have written tail recursion as this is the last step in the recursive method. Now if you do a single change, right, if you just let me run this and show you. As you can see, you are able to print from 5 to 1, but if I remove this line from here and if I put it above the print call, so first it will do the recursive calls and then it will, once it's coming back, then it will print those. So now it is able to print in a reverse manner, which is a increasing order 1 2 3 4 5. Same program. All we did, we just changed the place where we were calling this recursive method. So you have seen, if the recursive call is before your logic or after your logic, it can make a really big difference. That's why we have to put recursion very carefully in the program. If you remember, when we were implementing the string algorithms, right, the string related programs, we implemented this is palindrome. So there also we implemented this is palindrome method, and here also we have implemented, but here we implemented using recursion. Okay, so how we implemented it? We called our is palindrome method. Again we created our recursive call. Okay, I have named it madam. This is supposed to be word. Okay, I could have just refactored it, but that's fine. Okay, so you have passed that particular word. You pass the first index, which is 0, and the last index, which is word.length -1. And how you're doing these checks? After every single recursive call, if first character is able to match with the last character, okay, then you're increasing the index of the first character and decreasing the index of the last character. Again you're doing comparison. Again increasing the first index, again decreasing the last index. Again you're doing the comparison. It keeps on doing the comparison till it reaches the mid element, or start goes beyond the end. That's the same logic we have written here. If start is greater than equal to n, you should return, Or else what you do, for every single index, do the comparison, make sure they are equal, and again do the recursive call by doing the increment in the start and decrement in the end. And that's how you will know whether this is a recursive call or not. And you're getting true, as you can see. Let me run it again. So as you can see, we are getting true, which is this only. And if you pass something different, I'm passing my name. My name is not palindrome. Okay. So if I'm running this, I'm supposed to get false, and we are getting false. So that was the basic, very basic understanding of what is recursion, how we use it in our recursive calls. And there are so many applications of recursion in our computer science. So we'll be understanding them one by one. Okay, it's not something that you can understand in a day. Okay, although people say they understand recursion in just 5 minutes because of that factorial method, trust me, it goes beyond your factorial method. And this is just a basic understanding of knowing what is recursion. So I hope you were able to understand what recursion is and got some understanding to explore it more or to increase your understanding on this topic. So that's all I wanted to explain as part of this video. See you in the next one.